We're going to describe what is meant by the term periodic trend, which we already did in the previous part. Understand and explain the period and group trends of different properties among elements. We're going to finish this off by talking about the last two sections, and then we're going to describe the effect of an atom when it becomes an ionic radius. Keywords again: periodic table, period, group, atomic radius, ionic radius we covered in part 1, and we're going to look at today electronegativity and ionization energy. So periodic trends part 2. So we'll go straight into ionization energy, and this is defined as the amount of energy required to remove one electron from a gaseous sample. Remember previously we talked about ions for ionic radius, and we said ions can gain or lose electrons. Well, in terms of ionization energy, it's always about removing an electron, and it must be a gaseous sample that we remove the electron from. Now, positive ions are formed when we remove these electrons, and this ionization energy is an indication of how strongly an atom will hold on to its valence electrons. So the harder it is to remove that valence electron, the higher the ionization energy will be. And removing the first valence electron is known as the first ionization energy, but we can remove 2 electrons, 3 electrons, and so on. If we remove 2 electrons, it's called the second ionization energy. If we remove the third electron, it's called the third ionization energy. The trends for ionization energy. So as we move across the period, the first ionization energy generally increases. Now what you've got to remember is as we go across the period, all of the valence electrons are still located in the same principal energy level. But what happens is the nuclear charge on that nucleus, so the positive charge on the nucleus, is increasing, and this causes the negative electrons to be more strongly attracted to the nucleus as we go across the period. This makes it more difficult to remove those outer electrons. Okay, and if it's more difficult to remove the outer electrons, it means that ionization energy will be higher. So as we go across the period, the electrons become more difficult to remove, and therefore the ionization energy increases. Now as we go down the group, the ionization energy will decrease, and this is because the valence electrons are increasing in their principal energy level. So as we go down the group, there are more principal energy levels, and therefore these electrons are further away from the nucleus. Now because they're further from the nucleus, they are shielded more, and there is less attraction between the positive nucleus and this negative electron. It means it's easier to remove, and therefore the ionization energy will be much lower. Okay, moving on to something called electronegativity. Now you may never have heard of this term, but the electronegativity is the ability of an atom to draw electrons towards itself in a chemical bond, and sometimes you may see this called electron affinity. Now the better it is at attracting these electrons, the more electronegative it is. So electronegativity values are expressed by a unit called Paulings, and they are always 3.98 or below. Okay. Now electronegativity trends. As we move across the period, the electronegativity increases. This is because there is a stronger positive nuclear charge and there's the same principal energy level, so therefore it can attract these negative charges easier. Okay, it can pull the electrons towards itself more easily. Now as we move down the group, there are more principal energy levels, there is more shielding from that nucleus, and therefore it is not as good at attracting the electrons towards itself. And as you go down the group, it becomes less electronegative. Just to finish, we've got this summary slide here, which is going to talk through the atomic radius, and we've got ionization energy, electronegativity, and it doesn't have the ionic radius on, but I will speak through that anyway. So if we take the atomic radius, firstly, we said as we move down the group, the atomic radius will increase, and as we move across the period, the atomic radius will decrease. Now for the ionic radius, as you move down the group, the ionic radius also increases, and as you move across the period, in general it decreases from 1 to 14. As we get to group 15, we get a negative ion, and the negative ion increases in size before decreasing across to group 17. Ionization energy across the period will increase, and as you go down the group it will decrease, And electron affinity, or also known as electronegativity, is exactly the same. So across the period it will increase, and as you go down the group it will decrease. Thank you for listening to this presentation. That's the last presentation for chapter 5.